Hello friends, did you try the questions which were given in the video at the end of the chapter Archimedes Principle? If you haven't seen that video, do check it out. I have shown the experiments on Archimedes Principles very easy for you. And at the end of the video, I am giving some tricks that will help you to remember the Archimedes Principle forever. So I will be putting the link below in the description box. In this video, we are solving the top 3 questions on Archimedes Principle. Let me pull out those on concept board for you. Here are the top 3 questions and let us solve those one by one. An object weighs 200 gram force in air and the weight is 170 gram force when completely immersed in the liquid. Calculate the loss in weight of the object and the buoyant force of the object. First, let us draw the diagram. Object is weighed in air with the help of the spring balance, and the weight of the object in air is 200 gram force. Now when the same object is completely immersed in liquid, the weight is 170 gram force. As we saw in the video, the loss in weight is equal to the real weight minus the apparent weight. The real weight is equal to the weight in air, that is 200 gram force, and the apparent weight is equal to the weight in liquid, that is 170 gram force. Therefore, loss in weight is equal to real weight minus apparent weight, that is equal to 200 gram force minus 170 gram force, that is equal to 30 gram force. Therefore, loss in weight is equal to 30 gram force. The buoyant force or the upward force is the force of the liquid on the object, and I will mark it as F. And as we learned, the buoyant force, that is the upward force, is equal to the loss in weight of the object. So it will be the same value, 30 gram force. Question number 2. What is the apparent weight of the floating body? So what do you think? Let us take an example. See, the ball is here and let us measure its weight in air. This is the real weight. And as you can see, the weight is 150 grams or 150 gram force. Now let me lower down this ball in water. What is the reading of the spring balance? That is right. It is 0. That is, this floating ball is weightless in water. And that is true for any floating body. Floating body has the 0 apparent weight. Now let us take a look at our formula. So the formula is apparent weight is equal to real weight minus upward force. Now since the object is floating, the real weight is balanced by the upward force. Hence the upward force is equal to the real weight. So the apparent weight becomes 0. So that is correct. It is weightless. Question number 3. A body of mass 5 kg displaces 1000 cubic centimeter of water when fully immersed in water. find the volume of the body and the apparent weight of the body in water. Let us see. We have the beaker with full of water, and there is another smaller beaker to collect the displaced water. Since the body is completely immersed in water, volume of the body is equal to volume of the water displaced. So it is going to be 1000 cubic centimeter. Apparent weight is equal to real weight minus upward force. Since we have given the mass of the body, the real weight in air will be real weight is equal to m into g, where g is the acceleration due to the gravity and the upward force is weight of the liquid displaced. So let us use the formula. Apparent weight is equal to m into g minus into bracket VL into DL into G bracket close, where the mass M is 5 kg and G is the acceleration due to the gravity, which is 10 meter per square second. VL is the volume of the liquid displaced, which is 1000 cubic centimeter. DL is the density of the water. Since it is not given in the question, we have to take the known values of 1 gram per cubic centimeter, and G is 10 meter per square second. So let us plug the values in the formula. So the buoyant force is equal to into bracket 5 kg into 10 meter per square second bracket close minus into second bracket 1000 cubic centimeter into 1 gram per cubic centimeter into 10 meter per square second bracket close, that is equal to 50 kg meter per square second minus 1000 gram into 10 meter per square second, that is equal to 50 kilogram per square second minus 10 kilogram per square second, that is equal to 50 Newton minus 10 Newton is equal to 40 Newton, that is 4 kg force. So the buoyant weight is 50 Newton minus 10 Newton, which is 40 Newton or 4 kg force. I hope you found these questions helpful. I also have a part 1 video that covers the Archimedes Discovery. I recommend you to watch that well. I will be putting the link in the description below. Be prepared for both power and courage to do anything. Get energy in your body and mind. Please like it, share it and subscribe it. Thanks for watching.